In this section of the video, we're going to look at an alternate way to do electron configurations. Instead of having to write down the 1s, 2s, 2p, 3s, 3p, 3d, and so forth and so on, which you can do. This is an alternate method. I don't care which one you choose to do. Is you can use the periodic table itself. So if you notice that the first two columns, so this is 1a, 2a, this is 3a, 4a, 5a, 6a, 7a, 8a, and these are the B's, and they don't go from 1 to 10, so I don't know which order they're in. But you'll notice that, and I look at this as being a castle, okay? And so in this castle, I have the two towers. This is the small tower, and this is the big tower. And then you have the main body of the castle here. And then you have the moat, okay? So it was a very bad architect. If I look at this first tower, it's only 2 elements wide. And which one of these is only 2 elements? And it happens to be the S's. So therefore these are S's. If I look at this tower over here on the right hand side, it's 1, 2, 3. Let me change over to my pointer. If I look at this tower over here, okay, I notice it's 1, 2, 3, 4, 5, 6 blocks wide, okay? And if I think about it, what letter goes with 6? And it's the P's, okay? If I look at this block here, the main body of the castle, it is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, okay? And 10 happens to go with D. And if I look at the moat, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, which happens to correspond to F. Now, the one problem that students tend to have is that you'll see this is, and if I number down, this is 1, 2, 3, 4, 5, 6, 7. So when I'm on row 3, it's 3S and 3P. However, when I go to row 4, it's 4S, and then the next one, we're going to go back up here, is 4S, 4P, 4D, 4F. So when I'm doing this, okay, I go 2P, 3S, 3P, 4S, and then back to 3D, okay? So all of these, you'll notice, are N minus 1, where this is N, okay? And the F's are actually N minus 2, again, where this is the N. So you notice that this one star corresponds to this star. Color. So this corresponds to that. This corresponds to that. Okay. And so it actually goes 6S, 4F, and then 5D. Which if I go back to up here, if I do 5S, 5P, 5D, 5F, 6S, 6P, 6D. There's not such a thing as 6F, but in theory, okay, so I go 4P, 5S, 4D, 5P, 6S, and then 4F. So it is 6S and then 4F in the buildup. So this is using the same way, but I'm only using a periodic table to look at this. Okay, so these are examples we did in section, in an earlier section about the buildup principle. This one is arsenic, okay? And so if I look at this, okay, I'm on row 4. So my last, and here is the division, here and here, okay? So if I look at this, these are P's. So I'm at 4P, 1, 2, 3. So my last electron is 4P3. And then, so I basically go, okay, across. That's 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, Now, when I drop into D's here, it becomes 4 minus 1, so it's 3D10, and then I get to my 4P3. So this is the method I prefer. And of course, if I want to use the noble gas configuration method, then I would look at, do it in a different color, do it in green. I don't really care about the rest of that. Okay. To do the noble gas method, again, I'm looking at arsenic. Okay, so I go up 1 and over. So it's argon in a bracket. And then argon is 3sp, so I start out at 4s2, 3d10, 4p3. So this is the long way, and this is the short way. Okay, and nice thing about doing the noble gas with the using the periodic table is that as long as I count down 1, 2, 3, 4, 5, 6, 7, then knowing 18, 19 starts at 4s. So after argon, I write the 4s2. Okay, I suggest that you pause it and try doing it this time on your own. Again, this is one we did earlier, but okay, this is nickel. Okay. So nickel, the last electron is, these are 3D, so it's 1, 2, 3, 4, 5, 6, 7, 8. So my last electron is 3D8. So doing this a long way, it would be 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and then 3d8. Or again, I go up and over. The last noble gas is argon. And then after argon, I start at 4, so it would be 4s2, 3d8. So those are the two configurations. And so that's how you use the periodic table to do the electron configurations.